The topic we are going to discuss about is thermochemistry, and the subtopic is enthalpy. So let's see an experimentation first. Consider a gas enclosed in a cylinder having a frictionless piston. A quantity of heat Q is given to a system, which is now kept at constant atmospheric pressure. First law of thermodynamics में हमने सेम एक गैस सिलेंडर को कंसिडर किया था हैविंग अ फ्रिक्शनलेस पिस्टन, बट वहाँ पे जो हमने हीट सप्लाई की थी उसमें हमने एटमॉस्फेरिक प्रेशर को कांस्टेंट नहीं रखा था, बट यहाँ पे हम एटमॉस्फेरिक प्रेशर को कांस्टेंट रखते हुए हीट सप्लाई कर रहे हैं. So a part of this heat is used to increase the internal energy of the gas. The rest is used to do work on the surroundings. This work is done by the gas when it expands against a constant pressure. To take account of increase in internal energy and accompanying work done by the gas. So वो एनर्जी जो हमने सप्लाई की गैस को, उसका जो कुछ पोर्शन था उसने इंटरनल एनर्जी को इंक्रीज किया, और जो बाकी का पोर्शन था that is used in doing work against a constant pressure. So the previous scenario was explained by another property of system that is called enthalpy of heat content, and it is represented by H. So enthalpy is defined as the sum of internal energy and product of pressure volume work. Its expression is H for enthalpy equals to internal energy plus product of pressure volume work, that is PV. It is a state function measured in joules. Let's see what changes occur in enthalpy of a system. It is not possible to measure the enthalpy of a system in a given state. However, change in enthalpy delta H can be measured for a change in the state of a system. हम किसी सिस्टम की enthalpy को measure नहीं कर सकते, लेकिन हम change in enthalpy को जरूर measure कर सकते हैं. A change in enthalpy is written as delta H equals to delta E plus delta into PV. जो expression था that was H in equals to E plus PV, तो हमने दोनों expressions के साथ जो है वो delta को multiply कर दिया, यानी कि change को multiply किया. So जब ये डेल्टा अंदर पी वी के साथ मल्टीप्लाई होगा तो ये एक दफ़ा वी डेल्टा पी बनेगा और दूसरी दफ़ा ये पी डेल्टा वी की फॉर्म में लिखा जाएगा. Since the gas is kept at constant pressure, so delta P would be 0. Hence, delta H equals to delta E plus P delta V. In case of liquids and solids, the changes in the state do not cause significant volume change, so delta V would be 0. For such processes, delta H यानी कि change in enthalpy and delta E यानी कि changes internal energy are nearly same. So delta H is almost equals to delta E. क्योंकि solids और liquids में जब state change होती है तो significant volume change नहीं होता, that's why delta V would be 0. जब delta V 0 हो जाएगा, this whole expression would be 0, so delta H would be equal to delta E. So according to first law of dynamics, delta E equals to Q plus W. If W is pressure volume work done by the system, then W would be minus P delta V, क्योंकि work is done by the system. So by substituting the value delta E equals to Q, W would be minus P delta V. Putting values, we get delta H equals to Q minus P delta V plus P delta V. Q equals to minus delta P into V plus V. Since pressure is constant, so delta P would be 0. Therefore, we get delta H equals to QP. So the physical meaning of the expression we have deduced is that heat supplied at constant pressure is equal to enthalpy, that is H or delta H. The reactions are carried out at constant pressure, more frequently used than at constant volume. Here we have a practice MCQ. Heat evolved and absorbed during the chemical change at constant pressure is delta H, delta V, delta E, or delta H plus delta V. And the correct option is delta H. We have read in the previous slide. Let's discuss another question. Delta H represents the enthalpy change at 0 degree Celsius and 1 atm pressure, 0 Kelvin and 1 atm pressure, 25 degrees Celsius and 1 atm pressure, 25 degrees Celsius and 2 atm pressure. And the correct option is 25 degrees Celsius and 1 atm pressure. That are the standard conditions. So this was all about enthalpy. I hope you have understood it well, and thank you so much.